Hi everyone, I'm excited to introduce you to a citizen science project called Plecoptera, which focuses on aquatic insects because they play an important role in freshwater ecosystems as an indicators of water quality. Plecoptera aims to document the family-level diversity of aquatic insects and water quality in Costa Rica. Led by our team, Samantha, Sayaku, Pañaca, Nanda, Roberto, and volunteers, this project is an excellent example of how citizen science can contribute to scientific research to promote a deeper understanding of the aquatic resources around us. Throughout this presentation, we will explore the 6 citizen science project stages and exciting information about the Citizen Science Initiative. So sit back, relax, and let's dive into the world of Plecoptera.
In developing this project idea, we narrowed our project goal to water quality of freshwater systems. Water is essential for all life, both human and non-human, animal and plant. And in complex social ecological systems, water is an undeniable link that can be damaged if proper care isn't taken to maintain high water quality. Water quality can be compromised due to a lack of appropriate wastewater infrastructure, as in gray water or black water discharging directly into streams and rivers. Or, in agricultural areas, the use of agrochemicals and nitrogen fertilizer runoff can cause cascading effects to the freshwater systems, which directly supports ecosystems, livelihoods, and human health. Ecologically, polluted rivers depletes aquatic ecosystems that have a cascading effect on soil health, plant populations, and food webs. Livelihood activities that are potentially impacted include fishing and other food sourcing, swimming, washing, and drinking water. The presence of certain contaminants in our water can lead to health issues including gastrointestinal illness, reproductive problems, and neurological disorders. Vulnerable populations are often the most at risk of illness. Citizen science is the right approach for this project because it will increase people's connections to their water source in various communities, and it also increases the amount of data that can be collected, rather than if only researchers and institutions were in charge of monitoring water quality. This information gathered in this project is also mutually beneficial for both the communities, the citizens, and the researchers and institutions in which the citizens are a part. The project is also accessible for people in different communities as it requires little resources and training.
We split the development of a project into 5 steps. First, the development of a mobile app and a web page for the submission of records by the collaborators, training sessions through videos and digital tutorials, follow-up spaces with the people and communities that actively participate in the project, data reviews with experts and qualified people to maintain the data quality, and finally, feedback sessions with the participants of the project as well as to the civil society in general. Citizen scientists must choose an aquatic resource, collect a representative sample of a microhabitats, use the identification guides to count the number of individuals per species, submit the data via app or website, and share information such as water coloration or weather conditions. Each person can repeat the process in dry, transition, and rainy seasons for several years to monitor the water quality changes. Each family of aquatic insects has a score according to its degree of water quality indicator, and by adding these values, a result of a water quality based on the biological indicator will be automatically obtained in the app using the Biological Monitoring Working Party (BMWP) protocol adapted to Costa Rica. And now we will learn a little bit more about data management and analysis plan.
In our project, it is recommended that student scientists observe and collect the data, and experts interpret the data into an analyzable form, because incorrect water quality result can lead to health problems. For data accuracy, we need 4 steps. 1. Data cleaning. 2. Statistical analysis. 3. Data quality assessment, and 4. Interpretation and qualitative analysis. In terms of data cleaning, first of all, student scientists are encouraged to use expert certified field guide to avoid bias and errors. When they enter the data, it requires submission of the name of the identified species and a picture of it. But if participants cannot accurately identify the species, they can choose not sure. Final validation or certification of the species is provided by experts. To make the task simple and easy, participants are only asked to mainly work on presence or absence of aquatic insects and identification of their genus. However, water quality evaluation requires not only index insects, but also data such as weather, water temperature, water flow, water color, and odor. Therefore, participants can also enter option by choosing from a list of this information as references for experts. We may undertake simple analysis as quick feedback to the participants before deep analysis. To ensure the accuracy of the data, we require submission of photos, link the location information as metadata, not just species names and photos. It also helps identify spam data. Data on index species collected by student scientists, data on species identified by experts, and water quality data interpreted by experts will be accessible to stakeholders, and they will be saved on the platform after data encryption to protect data privacy.
For community engagement, the initial stages to identify the project participants. In this project, the primary participants will be Costa Rican residents who live near rivers and lakes. To be more specific, the anticipated participants will be community members who have environmental and community concerns, and other people including students and younger generations who are interested in this subject. However, there will be no limitations on the project participants in terms of age, level of education, professional experience or expertise, or access to technological resources. So, what will we do to encourage public engagement in this project? The initial phase of obtaining public engagement is project promotion. The project will employ both online and on-site strategies. For online promotion, the project will utilize social media such as Facebook, Instagram, Twitter, and LinkedIn, as well as newspaper and science magazines. We will also have our own platform and mobile application for public engagement. Moreover, the project will connect with existing citizen science networks and other partner organizations, and through these networks and platforms, we will promote our project and encourage community engagement in it. For on-site promotion, we will conduct campaigns, roadshows, workshops, community meetings, education and awareness programs in the targeted communities. To maintain sustainable engagement of the participants, the project will provide different trainings both online and in person that will increase participant knowledge and awareness, as well as their capacity and skills that will be valuable in their careers and real-world setting. It will promote volunteers' motivation and confidence for long-term engagement in the project. Aside from project activities, there will be regular online and on-site social activities, including social gathering, conversation and discussion among participants, researchers, and experts to foster social and project connections among participants. Moreover, volunteers will have the opportunity to discuss and consult with professional researchers and experts via the platform. To maintain the long-term engagement of volunteers in the project, periodic evaluations on various dimensions of engagement, including participants' motivation, feelings, and behaviors, will be conducted. Volunteers are essential to the success of this project, and their contributions and efforts will surely be recognized and acknowledged. They will receive regular updates on their findings, as well as appreciation for their engagement.
For the project evaluation, we will have a look at three important components. Firstly, community environmental education. Secondly, application functionality. Thirdly, data quality. For community environmental education, we will have a look at self-reported improvement of knowledge in water quality that link to public health. For application functionality, we will have a look at user uptake user-friendliness, and accessibility features. And for data quality, we will have a look at data accuracy, data completeness, and the usability of data in scientific inquiry and policy. Methods and minimal verifications. For the first component, we will rely on impact stories and the number of community projects recorded within the platform. Secondly, for the application functionality, we will use our metadata to analyze demographic data, including user age, disability status, gender, and geographic information, to understand the level of user-friendliness and accessibility features within an application. Furthermore, feedback and rating of the application will be used to understand application functionality and accessibility. Finally, data quality, accuracy, and completeness will be assessed in comparison with reference data through random selection. We will collect information regarding the number of publications and policies produced using our data to also inform us of the accuracy, completeness, and usability of the data in terms of answering different scientific inquiries and implications for policy and decision making.